Hi everyone, my name is Amir Aryani and I am the co-chair of the Data Description Registry Interoperability Working Group at RDA. When Martin Feder mentioned about the bird of the feather session on the research data graph, I thought this is a great idea. This is what the community needs. There has been a number of initiatives in this space recently, and we need a conversation about how to link these projects together. So, despite my enthusiasm, I couldn't actually make it to RDA Plenary this time. As a result, I'm recording this presentation. I hope this provides an overview of the work by the DDRI working group and also provides a context for creating the research data graphs. Now, about the DDRI. It was created in 2014 with the idea of providing an effective method for interoperability between research data registries. It got the initial momentum from contribution of major data infrastructures such as NCI in Australia, DataCite in Germany, and even software providers like Vivo. And you can see the list of complete contributors and project partners on the working group website. Let me start by providing a background on the initial thinking and the interoperability model of the DDRI working group. The main question to answer was how to actually link datasets from different repositories where there is no direct data citation. For example, in this case, you can see a dataset on the Research Data Australia website. We have the title for the datasets, we have a list of authors for the datasets, and we have a description for the dataset. However, there is no direct citation to any other article or another dataset in other repositories. One thing that a librarian would be able to do is that she can actually search the name of the researcher who is the main or the first author of this dataset on the internet. In this case, we can actually search an associate professor, Catherine Belov. We can find her page on the University of Sydney website, and if we actually go to that page, we can see the complete list of all articles, including 105 journal articles. If we actually go to every single article and read the entire content, we would be able to find datasets in other repositories. In this case, we can identify a dataset from the Dryad Digital Repository. If we go to that page, we can actually confirm that this is a dataset by Professor Catherine Belov, which in this case marked as Belov K. Now, what did we achieve here? We actually said there is a dataset in ANDS, actually can identify the researcher. From the researcher, we go to a publication, and from the publication, we go to another dataset. Now, this chain of connections basically connect datasets in a way that we can say they are in the same context. This does not provide causality. It only says that if you are interested in datasets in ANDS, you might be interested in the dataset in Dryad. And this by itself is a substantial value add to lots of different repositories because it enables and promotes data discovery. Now, as functional and effective, this approach is manually, but it's not scalable. So to make it scalable, the working group between 2014 and 2016 created a software platform that called Research Data Switchboard. The system was basically automating the steps that I explained. It has a layer for data providers that collect metadata from different sources. It has the cloud-hosted computation core component that is actually called Switchboard. It resolves all the identifiers. It has a Google search integration. It does some fuzzy matching and does the name disambiguation to some level. And the result of this is the curated graph in a model that we call it research graph. So the research graph is really the product of the switchboard component when it forms the connection between datasets and all other elements in the research ecosystem. Now, let's specifically talk about the research graph meta model. One of the difficult challenges that we had to face from the day one was working with the heterogeneous metadata. The challenge is that linking metadata from different sources would lead to actually linking metadata with different structure. And to make it work, we had to adopt a minimalistic approach when we preserve the most critical metadata elements while avoiding the conflict resolution as much as possible. And there are four main node types in the research graph. There are data sets that are input and output of a research. These are the center orange nodes in our graph. We have the researcher profiles on the top, highlighted in green. These are often represented by researcher identifiers, mainly ORCID, but also we have the Scopus ID integrations. We have the integration with the National Library of Australia, and there are other sources that contribute to this part. We have grants that are funded research projects, and we have the publications that are the published scholarly articles. This also includes books and book chapters. As we speak, there is a new version of this graph model which is in progress. We are kind of in the process of alpha testing that, and that includes the research organizations, patents and softwares that are introduced into this ecosystem. The second challenge to address when we create a graph like this is the concept of hosting and curating a large-scale graph. The issue here is that as the graphs get bigger and bigger, it is more expensive to compute and it is more expensive to query. To address this problem, we had to work with the concept of distributed graphs, and we connected these graphs using the synthesize function. In this example on the screen, we have the graph cluster from ANS hosted in Australia. This cluster can be linked to ORCID by basically citation between datasets and publications. It can also be linked to the GACES graph by the link between the datasets and grants. In practice, we had to create and host multiple instances of the switchboard software. We have a cluster at GACES private network. We have the version on the Australian AWS cloud, and there is one that are hosted in Australian Research Cloud. These clusters together host more than 200 million nodes. If you are interested to access this data, we have started creating curated open access version of this graph. The first attempt was publishing a data descriptor paper in Nature Scientific Data last year. You can see that one on the screen, and there's a link at the bottom to actually access the Nature page. The next thing to talk about is augmenting research graph. This function enables us to use the research graph synthesize technology for domain repositories or institution repositories. One of the early adopters of the research graph technology is the National Computation Infrastructure in Australia. I'm going to use their data to demonstrate the function of augmenting data graphs. In this case, BlueLink is one of their key collections, and Peter Oak is the primary contact for this dataset. This is the Neo4j interface of Research Graph at NCI, and as you can see here, we have linked the Peter Oak node at NCI to his ORCID profile. This subsequently identifies all potential publications that are conceptually connected to the BlueLink database. Now, to demonstrate this step by step, let's look at the BlueLink as a starting node, and in this case it is connected to the researcher, which is Peter Oak. NCI node for Peter Oak will be linked to the ORCID record at ORCID, and that brings the list of publications from ORCID. Now, in the third degrees of separation, what we do is that we use a Scolex data, for example, in this case, to link the publication to datasets. And then that dataset also is linked to other publications. So with 3 degrees of connectivity, we actually bring information from other group of publications in the same area. This is the NCI graph that's augmented using the research graph technology. What happened here is that we had a GeoNetwork database. We created a Neo4j through the ETL process. Then the graph was augmented using the Research Graph Augment API. And then the result is augmented Neo4j graph database. We use the data visualization tool to actually present the graph, as you can see in this slide. In this format, the blue dots are the publications, the green ones are the researchers, and the orange nodes are the data sets that, as you see, they're an outer layer of the graph. To get a picture of what it means, let's look at the NCI graph before and after augmentation. So on the left, you can see the NCI original graph, and on the right, you can see the NCI augmented graph. As you can see, the NCI GeoNetwork database includes lots of different datasets, some publications, and some researchers. And what the Augment API has done, it used the augmentation plus the shortest path algorithm to actually connect these nodes in an effective way using the all other scholarly works. So what did we actually learn from the research graph case studies and early adopter stories? Well, one of the things that we found was the power of the trusted identifiers. Yes, we can use Google API. Yes, we can use fuzzy text search. We can use graph clustering and topic modeling and use all of these technology for author disambiguations and also for disambiguations of the grants and papers. However, all of these disambiguation algorithms, they all comes at a cost. Using the persistent identifiers, we have the much more accurate result, and also we have the less expensive result. So it's much more viable option when we have those identifiers in place. The other thing that we learned was working with a scholarly communication is literally working with a dynamic big data. To actually leverage the scholarly communication data, we need some kind of trusted services. We need fast services, and we need sustainable services. The last thing is, following the last point, we need to start connecting information rather than collecting them. Historically, in a lot of projects, they collect a lot of records. We have done this as well. And what we have found is that the process of collecting records from different publishers and different repositories does not necessarily lead to a sustainable and a fruitful infrastructure that it can provide value to the community. Instead, all of these informations are sitting in different islands at different hubs, in different publishers, in different repositories, and the road ahead for us is actually finding the effective way to connect all of this information. So if someone needs to know all the possible links to a given data set, we would be able to query that live from all the possible sources rather than having the outdated collection in our own graph cluster. I'm sure there will be a lot of interesting discussions in the BOF that I'm going to miss, but please feel free to contact me on amir.aryani@researchgraph.org or send me a text message on Twitter. I trust you are going to have a very fruitful meeting, and I wish you a very happy time in Philadelphia.